Hi everybody, my name is Jeff McLaughlin. I'm a Principal Technical Marketing Engineer here at Cisco working on Catalyst switching, and specifically I work on programmability and automation of our Catalyst switching products. And I'm going to talk to you today about application hosting on iOS XE. As I said, I work on Catalyst specifically, but a lot of this does apply to other iOS XE platforms. It's just that my focus is Catalyst. And so I always like to start by telling people that, I became a network engineer because I like computers and I didn't want to be a programmer and I didn't want to be a sysadmin. And now I'm a programmer and I'm a sysadmin. And I'm actually liking it because I'm doing programming and sysadmin stuff related to network devices. So what we're going to talk about today is actually hosting and running applications on our switches and routers. So any of you remember this box, the good old 2501, the venerable box, when I did my greatest ever. When I did my CCIE back in 2004, my apartment was filled with these things. A lot of people didn't come over to my place because of that. But it's a classic old networking device, right? And this had a slow processor. It had a Motorola 68000, 20 megahertz. Great processor, but a little slow. Not much memory. Very monolithic iOS, right? It was basically one package. It did one thing. That was route packets, right? In and out. Push packets in and out. That was what the 2501 did. Now, obviously, there have been a lot of products since then, a lot of improvement. But the newest platforms, if you look at like the Cat9K that just came out, right? They're the exact opposite of that. They have a very fast processor. In the case of the Cat9K, we have an x86 processor. Our previous Catalyst products didn't have that. SSD expansion on some of them. You can go up to 1 terabyte on a 9400 series switch. The OS, a lot of customers don't realize this because they log in and it looks like the same iOS that they've known and loved for so many years. But it's modernized, right? It's a Linux-based operating system. It's not monolithic anymore. And so this box is capable of a lot more than what our old boxes were. Obviously, again, there were a lot in between the 2500 and this. I'm just trying to draw a contrast. And so we have all this computing power in our network that's kind of unharnessed. And so what this session is about is harnessing that. So again, fast x86 processor, SSD expansion, Linux OS, and multiple apps, just to reiterate. So what we can do is we can now spin up containers and VMs and actually install applications directly on the device. It could be Python, it could be a tool like PerfSonar, it could be Wireshark. Interesting thing on specifically the Catalyst 9K is they actually have Wireshark built into the platform. It's integrated in the CLI, so you can do a monitor capture and start up Wireshark. But for other platforms that don't actually have Wireshark integrated, you could spin it up in a container or a VM. And potentially if there were some CLI options that you wanted that aren't available through our integrated Wireshark, then in that case you could also install it and use that as an additional tool on the Catalyst platform. Python is actually a special case because we have a special dedicated guest shell container for running that. So it's a streamlined and much more simplified workflow to bring Python up. If you want to install other apps, there are a few more steps that you have to go through. But Python really comes with the OS starting in 16.5. So all you have to do is 2 commands to bring that up. And we'll demo that in just a minute. So what types of applications would we want to run on a switch or a router or something? Well, obviously, like I was mentioning before, performance and throughput testing, right? We have customers that, for PerfSonar, for example, if they use PerfSonar, they install a separate box, and that's what does their PerfSonar, responding and throughput analysis. So we can actually run an agent for PerfSonar iPerf, which I'll be demoing a little bit later on our device. Configuration management agents. This is really an interesting use case. Ansible does not require an agent. Puppet historically has, but they're updating their software and very soon they won't require an agent either. But there are several other configuration management tools that do require an agent. So if we needed to, we could build an agent and run it in a container on our box as well. Packet collection and analysis, I mentioned Wireshark earlier. Python-based apps, of course I said Python is a special case. There are a lot of things that you can develop yourself very easily, scripts and apps in Python. I had a customer who said they wanted to scrape some data off their switch and aggregate it on the box and then send some aggregate up to their network management system. I said, if you can write it in Python, we can make it work. Not recommended. Video games except Zork. I think we might be able to get Zork to work if there are any Zork fans. And one of my customers came to me and said, I told him about app hosting, and he's like, I got the best idea. Bitcoin mining. No. I don't know what TAC will do if you call and you're doing Bitcoin mining on your 9Ks. Can't promise it. You can try it. Be my guest, but I'm not sure that's a supported application.
But you're likely to be eaten by a GRU.
Yeah, exactly. Exactly. He knows Zork, right? So as I mentioned, on-box scripting is a bit of a special case because we made it very easy for you to enable this because it's a very specific granular use case. And so the way this works is on a switch or a router, you enable our IOX framework. This is the framework for bringing up the containers in the VM, so it's just one command. And then you just say guest shell enable, and that actually brings up a container with Python running in it. Okay, so that's all you have to do to get Python running. So there are a lot of use cases for Python. I'll show you a use case where we integrate with Embedded Event Manager. Also, for example, zero-touch provisioning. We've had plug and play on our devices for a long time, but if you want to do the more standards-based ZTP, you need to have Python scripting on the box because it uses Python scripting to actually bring up the box. Once the container is active and you're running a Python script, there are several ways that script can talk to the device internally. It can talk CLI, so we actually have a library where you can execute a CLI command directly. I'm really big on netconf and Yang models. So the good news is you can do netconf and Yang models actually inside the box. So you can talk internally using netconf. Syslog, other facilities we can directly connect inside the box. Yeah, go ahead.
Just to make sure I'm understanding, when you say CLI command, like Wireshark, for example, is essentially a containerized app running in a container, right?
Correct.
And I can interact with Wireshark through the monitor capture command. Can I interact with other containerized apps through the actual iOS XE CLI?
Well, you can't. You can interact with the Python through the iOS CLI, but you can't interact directly with other apps that way.
So I can't make like a command alias to interact with a containerized app?
Not directly. As I have Albert with me, who's one of our engineers.
So as a container, you can actually connect through the console that you can actually log in and have a bash prompt depending on your operating system. So you can then go into that container environment and execute commands there.
But I can't abstract it further, so I'm sitting at the actual iOS XE CLI and make my own little command to do that for me.
No, but you can probably run on top of guest shell and guest shell run, and you can run your own script there, and then you can make up your own script.
Gotcha.
So in terms of, as I said, I focus on Catalyst. Catalyst platforms in terms of what we support, Python 2.7 on the 3K platforms as well as the new 9K. We won't get Python 3 on the 3K. It's just an older platform. We're not going to support it, but you can do Python 3 on the 9K. Pip install, we all know that Python isn't much without its libraries, right? So you can do pip installs. So if there's a library you need, no problem. You can install it. One caveat there, some of them have binaries, and if there's a binary that you need, it may not work on the 3K because it is MIPS based and not x86, as I mentioned before, but most of them should work. And the app hosting feature, that's a 9K feature. Again, we need the x86 processor to do that. So from a Catalyst perspective, we're not going to do app hosting on the 3K. So I'm going to do a demo for you now, because we know live demos always work. So it's going to work, right? So in this demo, what's going to happen, I'm integrating a Spark. You're probably all familiar with Spark, our collaboration tool. And what's going to happen is I'm going to make a change to a 3850 that's in my lab. And what's going to happen is I have Embedded Event Manager, which has been around forever, right? It's actually a powerful tool in and of itself, EEM. But there's some things it can't do. It can't do a REST API, for example. So what EEM is going to do is detect the config change that I make, and it's going to call a Python script on box, okay? And then that Python script is going to go and do a diff, see what changed in the config, and post it using REST APIs to a Spark room. So it's actually calling Spark via REST APIs from a switch in my lab. Sound good?
Yeah.
So let's do this. I'm going to sit down here to make it a little easier to type. So I have my Spark room open here, and it's kind of a lonely Spark room. It's just me and my Catalyst switching bot, but normally you'd probably have your whole operations team sitting here. And if I go to my switch, this is a 3850 disconnected, but that's easy enough to fix. It timed out. And so what I'm going to do, before I go and actually fire that off, I'm just going to show you, I can say guest shell run Python on here, and this is going to drop me into a Python prompt on my 3850. This is running 16.5, by the way. So I'm in an interactive Python prompt here. I can say, print hello, whatever, and it works. The CLI thing we were talking about earlier, we have a library for that. So I can say import CLI, and then from that library I can say CLI show version. So if you have to execute a CLI command, you can do it that way. Okay, we could assign that to a variable or do any of those things that we would normally do with the script. So I have a script, as I said, already set up on here. It's going to be triggered by EEM. And what I'm going to do, I'm just going to go in and I'm going to go into conft. I'm going to set up a VRF and we'll call it, how about tech field day. That's good enough, right? And we'll give it an RD of, I don't know, 100, 200. Doesn't really matter. All good with that. And so I've just put a VRF in there. When I exit out, that's a config change, right? So I'm going to go back to my Spark room. What's going to happen, it's going to take a second because the box is going to detect that there was a change, and then it's going to do that diff, and it's going to send it via REST API. So it popped right up there. The pluses, because I actually use the diff library, the pluses mean we added something, right? If I take something out, if I go back in and delete that, clean it up, what's going to happen is you'll see that same thing with minuses, okay? So REST APIs directly called from a switch. Boom, there it is, okay?
Nice.
So you could have in that script one of those, something from the CLI library that throws an output and then have that output thrown out to Spark.
Exactly, and in fact, the way this one works, I actually use the CLI library to basically scrape the running config, and I keep a copy. So as you make changes, I keep a backup of what the last config was. I just run a diff based on that, and that's using the CLI library to collect the running config.
Where's the diff run? Is that backup on box?
The diff itself is run in the Python script on the guest shell container. The configs are stored on the box on the flash. Okay. So I just save
And it
them.
just goes and looks in there for them?
Yep.
Yeah.
So there are a lot of different ways you could do it, obviously, but that's the way I chose to do it for that case. So that was our demo. So we'll talk about app hosting now, more specific app hosting cases. And so again, the basic idea of app hosting is that we want to be able to install multiple apps on our device. And we support both Linux containers, okay, LXC containers, as well as VMs. Okay, so we can do containers or VMs. We can do a full-blown KVM, VM if you want. IOX is our management and orchestration tool that we use to do this, to spin up these containers, manage them, install them, destroy them, etc. Okay. I'm going to give you a little look under the hood of IOX and how all of this works. So basically, this is a blown-up diagram of what's going on the device itself. We have this Cisco application framework here. This is a part of that IOX framework, or I don't want to say ecosystem for you guys, but you know what I mean, right? It's a part of IOX. So it's Cisco application framework. That's what's actually dealing with spinning up and managing these containers and VMs on the device, okay? So again, we can do Linux containers. You're probably familiar with this, but a container, it's very lightweight. It doesn't have its own Linux kernel, right? So that means it's actually running directly on the iOS XE kernel itself. Whereas a VM has its own Linux kernel. It doesn't need to run directly. So this is better for things that need like low-level access, right? But there's also a little bit more of a security risk, because if you hack the kernel here, you're hacking the iOS XE kernel, right? So it's something you have to take into consideration when you're creating these. You know, what risk are you willing to take? What do you need to do to secure that container to make sure that doesn't happen, right? VM, obviously, it's not quite as lightweight as a container, but it has a little bit more security, and there's a little bit more that you could do with a VM in that regard. So on-box management tools, the way that we spin these up, the way that we actually manage this, again, get the package onto the device, start it, manage it, etc., is using one of several tools. Okay, the most obvious one is CLI. I'm actually going to show you that, so we can copy a package over, start it, do all that using CLI commands. We also have Local Manager on the device. Local Manager is basically the device web UI, right? So you can hit the IP address of your switch or router or whatever and pull up the web UI. On there, we have a web UI to manage applications on that box. We also have external management tools. IOX Client is a client. It's a CLI-based client. It works on Linux, and it works on Mac OS. It will also work on Windows if you have a Linux VM on Windows. You can run it on Windows, but it won't run directly on Windows. Fog Director is a tool that we have. So obviously, Local Manager and CLI are focused on the specific box that you're working on. IOX Client can connect to multiple devices, but one at a time. Fog Director is an application that we have. It's really a part of our IoT suite of applications, but it's really intended to manage multiple devices. Because obviously, if you're doing this, you don't want to do it over and over and over again if you have 50, 100 switches. So those tools are used to spin up, destroy those containers. They're also used for packaging the containers. So an important point here, because you might say, well, could I just bring up a VM and do an RPM install or a yum install or something of the application that I want? And the answer is, yeah, sure, you could do that. Of course you could do that. But again, if you're managing 50, 100, 200 devices, do you really want to go RPM install that same application over and over and over again? So an important part of the solution isn't just the fact that we can run the containers and run the VMs on the switch or router, but the fact that we provide tools for packaging your application up so you don't have to go through that process over and over again. Make sense? Any questions so far?
Just one. Does the 3650, 3850 support MIPS LXCs?
No.
Okay, just checking.
No. Yeah, on the 3650, 3850, the only thing you're going to get in terms of app hosting would be Python-based apps, basically. Okay. In terms of actually getting a VM or container packaged and onto the device, there are two different workflows. Good news is the container workflow, we can use Docker tools to actually build the container. So we can do a Docker build, use a Docker file, use all the, pull something down from Docker Hub. We can do all of that to build our container. So those are familiar tools. Anybody who works with containers knows Docker usually. We have to add some metadata and some other stuff to that Docker container before we can actually run it on iOS XE. So there's a packaging step that has to take place. And that's the case for a disk image as well. Okay, we take QCOW, 2 disk images, which is a pretty standard VM disk image, right? So we run it through a packaging tool. In the case of like a Docker container, which is what I'm going to be showing you today, what I did was I used our IOX client. That's that CLI-based tool. And you just provide some additional, again, data about how much memory it needs, et cetera. That disk image, basically the file system, gets put into a file called artifacts.tgz with a couple other things. And then there's a YAML file that gets added by the packaging tool. All that is bundled up and then created. We have a new packages.tar file, which is created from that. So when that's done, the package.tar file is what you copy over to the device. So you don't need to worry about all the different components of it. Okay, so that's our packaging system. Another demo. We're at demo time again.
Again?
Yeah. So this time what I'm going to do is, we have the package file already copied over to our iOS XE device. And so we're going to spin up an iPerf container on this. So let's get out of here. Make sure that my server terminated. So I have an iPerf server actually running on another Linux box. So I'm going to go back to my iOS XE device. I have timeouts on all of them, so we get logged out occasionally. Okay. So on here, if I look at the flash, include package, just make it easy. Just go dir, it's a little bit easier. So you can see that I have package.tar on there. So I already did the Docker workflow because we didn't have time to do the whole thing, and I've copied it onto the flash. Okay, so that's sitting there. So what I'm going to do is there's a few steps to bringing this package online. So what I'm going to do is app hosting. That's the commands for this app hosting, install, and I have to say app ID. So for every app, we're going to give it an app ID. That's a name that we choose. I'm just going to call this TCP bouncer because that's basically what it's doing. And then I just have to give it a package name, and that's going to be flash package.tar. You'll see it'll just take a second, and it's going to deploy that. Now, if I try to activate that at this point, it's going to give me an error. App hosting, activate app ID, TCP bouncer. And it's going to tell me that there's no interface configuration. So we're bringing up a VM, and as you know, or a container rather, but a container or a VM, you need to have a network interface, right? So we actually have to specify the network interface before we can bring this up. And what I've already done, I've created a virtual port group interface on the switch, and I've made it an IP unnumbered interface off of another one. Think of the virtual port group. If you've worked with like ESXi, you know, you have port groups there where you can attach several things. That's all it is. It's just like an internal mapping of ports, right? So I've done that already. But what I need to do here is I'm going to go app hosting, and we're going to give it the ID of that app we just created. And under here, there are just a few options. We're going to create a VNIC, okay, VNIC. I'll just show you all the options as I'm doing it. Gateway 1 and virtual port group 0, okay. Guest interface, that's just the interface number it's going to get on the container VM or whatever, so we'll use 0. And then we give it an IP address, guest IP address, 72.26.244. Why don't we do 85, I think would work. Net mask of 255.255.255.0, so I'm just giving it all the parameters for that interface and the gateway, 72.26.244.1. Okay, so I've just given it the interface. So now when I back out of here, and I run that activate command again, we should see it go activated. Okay, so we just had to do that, so told us we weren't quite there yet. So the only other step that I have to do is to start it.
Did you pull that addressing dynamically?
Yes, actually you could. Yeah, you don't have to do it statically. You could do DHCP as well. So this point tells me the app is running, so I'm just going to go app hosting connect again, give it the app ID because we can have more than one, right? Bouncer, and I'm going to go to the console port on that. And you'll see that I'm sitting at a Yocto Linux prompt. So that's my Linux container on here. I'm going to go in as root. Right now on this one I don't have a password, obviously. You know, that's up to you. And so I've set up my iperf3 server you saw earlier. So I'm just going to say iperf3-c 172.26.244. I think he was 124. And what's going to happen is you'll see it'll run an iperf test. Now these are on the same subnet that I'm sourcing and connecting to, but just to prove the point that you could do throughput testing directly to your switch. So when you get that call of the user who's complaining, you now know, okay, we're good to that switch. It's not the network. It's our favorite phrase in networking, right? It's not the network.
That's
Good?
Very nice.
Good. So a couple more things since we have just a few more minutes. I want to just talk to you a little bit about Fog Director. I'm not going to actually run it right now, but I'm just going to show you really quickly. So again, Fog Director is just a GUI to do all of this. So that's not the only way to do it. I know you guys probably want to see the CLI. Again, we could start it up from the GUI on the local device. You're just clicking buttons to do that same workflow. You know, install a package from my local machine, activate, start, etc. It's the same thing. So if you prefer GUI, that's a point or a device by device solution. The nice thing about Fog Director is you can load in multiple devices and manage multiple devices. You can push an app out to more than one at a time, right? So you're not just stuck doing it device by device. So Fog Director is a nice solution for a larger management of your devices. So. Good, so we have a few minutes left. I have Albert Mack with me, by the way, who's from engineering, who developed a lot of this. So, so thank you, Albert, for doing it, first of all. Is there anything else you want to add to this, Albert, before we?
I think that we're pretty good here. It's good.
Yeah. So that's pretty much it. Any questions from you on this? Does it seem useful? You were interested in that.
Yeah. I was curious how it actually all worked together. I'm very new in all of the container world, so it's just curious.
Especially on switches.
Well, yeah. Well, why would I care in my data center? Much less why would I care on my switch, right?
Yeah, well, you know, as I was saying, there are several use cases for it. In the data center, I used to work on the Nexus side, and actually my last Tech Field Day talk was about running Puppet agents on Nexus. And that was one of the motivating factors for bringing up containers on those switches. So again, you still have that use case if you're using an agent-based configuration management tool. And again, you know, I've talked to customers where they're installing boxes all over their network to do perf sonar or something. And they love this idea because they don't need to install those anymore. They can just host the app on their Catalyst switch. Because again, as I said at the beginning, you think about it, you have a lot of unharnessed compute in your network, right? I mean, and usually you need to install an app, you're going to install a server at, you know, the location where you need it. Well, if you have, you know, a branch office with a router, you don't need to install a server. You know, if it has app hosting capabilities, install your app on there. Yeah.
I think there are other use cases, for example, for security type applications, you can run Snort with some enhancements or feature, but largely you can actually run Snort. And there are other security applications that we are going to trial with customers and making use of the same technology as well.
I was thinking just use reverse SSH tunnels to bounce out of an office from your office. Something more practical, right? You know, what are you seeing there? I don't know. You don't know how to describe your problem. Here, let me generate traffic from your office and land on my machine, right?
Yeah, I also think that the Python integrations are really cool. The EEM thing, like you saw, I mean, you can fire off a Python script if you lose an IPSLA probe, or if someone changes the config, or some other condition on the device. You could trigger it off a syslog message, whatever. As I said, EEM is actually a powerful tool in and of itself, but it's not Python. It's not Python, so there's a lot more you can do.
Right, there's actually some interesting integration with Python on the CSR as well, so you can imagine that interacting with something like AWS API, those kind of things. So that's also been in the work.
Oh yeah.